A quick recap for those guys who are just joining us from online. Engineering Science N1 Heat. Good afternoon, my people. King is in the mix. We're out here. We are discussing module number 4, which is Heat for Engineering Science N first. The N1 is what we are doing, and the textbook that we are using is the 10-week guide by Graham Olivier. I'm not alone today. I'm with my people. Please give some greetings. Please greet the world. There's 2 people who are watching already. Those people were not going to benefit if we didn't go live. So we did a great thing there, my friends. Anyways, let's just make a quick run through from the heat from the beginning. There we go. We spoke about heat and temperature on the first page. We spoke about a thermometer. You guys have to understand what a thermometer is and the difference between the 273 one, which is in kelvins, and the one that's in degrees Celsius. We spoke about heat, that heat can be transferred chemically. And we know that heat is a form of energy and so on. And then they spoke about heat being a form of energy that is transferred from a substance with a higher temperature to a substance with a lower temperature until both of them balance out. Measuring instruments that we spoke of, a thermometer, and on page 44, they talk about the advantages and the disadvantages. Please make sure you master those advantages and those disadvantages. One fact we know about alcohol is that it's affordable and it's easy to work with. Know those advantages and disadvantages. Know the advantages and disadvantages of mercury as well. Measuring instruments that are used. We spoke about a thermocouple. Where is the thermocouple? There is the thermocouple. And we spoke about a pyrometer. Those are theoretical equipments you should know. And now we're talking about the transmission. The different transmissions we can talk about. Conduction. Conduction happens on solid objects. And then you've got convection, which happens on liquids. And then you've got radiation, which happens on a vacuum or in a gaseous space. And then we speak of the effect of temperature on substances. These are the points that are affected when there's heat introduced. The first one is change in temperature. That's the obvious one. Something, if you burn something, obviously the temperature changes. That's the first one. Second one, change in color. I burn this pen, it becomes what color? Black. Change in shape. That is change in shape or change in structure, not so? Or they can call it change in state, right? And then the fourth one is what? Change in resistance or change in composition. Change in composition is good. Whenever pisatanda, the wood hell, the wood in itanda kuni in songa the huni, no so. Take the huni, what the one or he brown the huni lesh was fakamlilo. It becomes charcoal, no, so it becomes ash. So that is a change of state. It was in that state, now it's in the other state. If you take an ice block over by panga heat, for sure it's gonna change state from solid format to liquid. Heat the change from liquid to gas. Not so? Yes. Those type of things. So change in temperature is the first one. Anything that you put temperature in is gonna become hotter or colder. Color changes, it's over obvious. Usually it tends to become black. Not so? Yes. Change of state. State is good. Plastic is not over ice cube or ice cube. That's the change of state. That's the fourth one. And then change in composition. Composition is not the calcium carbonate. It's go change calcium oxide. Yadoweba na carbon dioxide. Rambangase and na limestone or heat glass. So these things can change when you introduce heat. Change in composition. You must know those things. Change in resistance. Change in resistance every day. When you have one or phone, you have a tablet. What happens? Yeah, no shoe pizza. You are cool down. That shows you that the heat impact has an impact on that phone. It means that it's function because of the temperature. So that change in resistance is the one. So operate. So you must take that phone and put it in a deep freezer. What happens if it's in a deep freezer? It decrease ayatsa sharp mara ya nana yatsa yashikoni apala ni lanto ya shuma huko freezer. It was zori remo ya operator what bring the temperature up. By panga stove we bika once. Zombo depend on Nepal. And then the fourth one, generation of an electric current. This one is number 6. Usually they will ask you about 5 points, but know about this one. Or what no generator mdagasi arrange go check a card changes the heat. As seen with the thermoelectrical. What are we saying there? Thermoelectrical pyrometer, a greater current will flow between different metals as they are heated. Here they are basically telling us that arawana material asafani, they will have a different movement of current as you introduce heat onto. Specific heat capacity, that's the second last topic that we can talk about. Specific heat capacity, we revive first definition yayo. Specific heat capacity, start by the definition. Specific heat capacity is at the bottom there. Is the amount of heat that 1 kg of substance absorbs to increase its temperature by 1 degree Celsius. Specific heat capacity is expressed in joules per kilogram degree Celsius, and the symbol C is used to express the heat capacity. La formula Q is M C change in T. Okay, one. Ela C ndio neneba doshimesa ngayo ela C ya MCT, right? And then they tell us specific heat capacity basically will tell you that the same amount of material, but for different uses. But the different quantities, yeah. Or abori 1 kg of water takes 4,100 and something joules to raise 1 degree Celsius. Come to Okwatao. Come to Abgati, it takes less. Come to Abgatinyana, it takes much less. Come to Saganesao, it's less. That's why we even talk about the element of eating. The people that eat less usually are the fattest, or the people that eat less are the thinnest. Like people who eat 2 quarters in 1 day, they become skinny. Anyways, hey, hectic. Now, the biggest thing you guys must know is this one on page 412. The specific heat capacity is heat capacity. Usually, the one that we normally work with is for water, which is how much? 4,187. Okay, Bonati. As when just give us some of the cremisas on it, they are not necessary to cram. And then what else? Specific heat capacity of certain known substances. That's okay. Heat capacity. Heat capacity combo like Q it's MCT. MCT as in the change in temperature is that triangular T. And there you have it. 1 liter of water has a large heat capacity and a lot of heat is required to heat the water to 100 degrees. A needle has... Hey, buddy. Hey. Hey. It's come on a man. Hola, Mwana. Hey. Hey. Ndikuzofuna bad ene kaite ndikutopedzisa class apa kaite ezvoyamba zvoneka WhatsApp ka message rivo ne rupitsa. Alright. Asongo wangu la open ndamba bana. Ayasvika mukudzisa baba. Abaita ula ofuko mfonera bombane wasibasa. Abato mufoinera mashaka abato mufoinera mi class ini mina hosi tabalabla later sure. Yeah, I'm not even hearing what was said. Yeah. What I mean? What like a page? Yes, it's possible. You like the page, share it with 20 people, and then I need people who are gonna share my content here, guys. Please, is there someone who can share? I saw someone was online yesterday. I think it was her. Big up to her. Thank you so much for being online. Who else was live on my lives yesterday? Was here guys on the chair. It was you, ne? It was you, ne? Keep it up, my darling. 10 marks is coming your way. Yes. There we go. Heat capacity of a body is the amount of heat required. So please watch the content, share the content. There's so many Facebook influencers. When I'm a boss, what about the Facebook, what about the social media? How many people have 1,000, 5,000 friends? How many people have reached 5,000 friends? Who's one? My boss, okay. Okay, my gosh, was it? Ni share bo mo shu bo rime. Don't say guys. That's much better. Anyways, please do log in when you see that message. It's not always about too much work without play makes Johnny a dull boy. Too much play without work still makes Johnny a dull boy. So entering as we go to Shmua Bagati eating at the formula and at the mini every day. Sometimes let's chill. Sometimes let's get people in the studio. Sometimes let's talk about music. Sometimes let's do whatever. Nonetheless, example 2 and example 3 are good examples for your homework. Kayla exercise 4.1 pala. Simple body hit him up. Comes read number 11, read number 13, read number 15, read number 24, Zukume Nepala. Comes in a good 8 here. And then the last important topic is linear expansion. Linear expansion is about the linear, kalaini, mutaro, linear. Ini mutaro ngasto. What? Mutaro, asinzalo. Mutaro. Ndira karete it's a so Swasumbezi or English and Chitsonga are not cousins because you can't say ndira and you say linear. But at least when you say line, what linear? You have for English. So relationship anya. Machisonga. Indeed. As long as you know what I'm talking about. The idea, my friends, is to make you remember these things in the test. I don't promote the element of memorizing. I promote the element of understanding. Linear expansion. Line, mutaro. Two things. Kaila linear experiment. Almost all substances will expand when their temperature rises. Similarly, almost all substances will contract when their temperatures are lowered. Numerous examples of this phenomenon can be given. Railway lines are installed with gaps between the rails to facilitate the expansion and contraction of the rails. We're going to face story. Or uchikopi chimwana chimwe chificha pangwa hiti chari expansion. Chabviswa hiti chia contractor chabachituku. And sometimes that can be very bad for business. Simply because if you find a bridge in a expansion, there is a phenomenon that usually happens. Yabariro expand. That's why you'll see a bridge will always have roller wheels on the one side and rollers on the other. This is for it to allow for that expansion and contraction. Why is it that? So that muse into a bridge in at the go after hours. Nama busy abo padziri na bonechituni na mini or dara ke pala diga railway bridge. But one sorry, this thing is very. You know what? Actually, if I can give you a simple example, monos wana pala cement de yopatiwa. If you put a cement down, without breaking it into pieces. When that thing settles, that shows you that I could end expand and no contract. It's failing to do that. That's why when you're putting your cement down, you must spread it and cut it into reasonable sizes. That's the whole construction. When it comes back to your mechanical stuff, I can give you an example of a bridge, and I can also give you an example of a train. That this is the railway line. If that railway line and by one, so you know that Chiporo is always in the sun. It's in the sun every day, forever, not so? Teach So once it gets heated, that metal will expand. And when the railway line, there was already this distance is the one that the wheel is here, the other one is on 100 millimeters. Hela train ya sky wana chiporo na expander. What's gonna happen? That thing is gonna get out of the chiporo and it will make a huge accident. Simply because your vandaila rabeshi chidimela chibacho dzula la chiporo. Who has seen a railway line ever in their lives? On top there, on those two pieces, the one leg of the train sits there and the other one sits there. So area pala contraction and expansion in the train cannot comprehend. The Apollo accidents is Gamanda. Let me get you a video that you will see, and I will prove what I'm telling you guys. So this expansion and whatnot is very critical in our everyday life. Let me try get onto YouTube and then I can show you what it is I'm talking about. Okay, I've got two people who are watching there. I'll give you an example of the bridge and I'll also give you an example of a train, and probably I'll catch another example of whatever. There's too many examples online. The next one on there, you'll have a phenomenon that's called LO. LO is like the length original length and actual length. Let me see if I can quickly Google that. I've got one person online. So far, we've done 16 minutes of streaming. That's not bad. If you can, please get onto social media and share those things. I think I'll just have to make examples first. I think it's a bit too much of a hassle. Bobby mask is the cap is easier. Skipper is better. Jewish. Now, Ruku Zote, Varengela Zote. Zote. Let's see if I can show you guys what I'm talking about. Yeah. Okay, let me share with you guys. Let's see. What I can do is that I want to have the kids. I want all my people to see what I'm talking about. I've got 3 people watching. There's a comment already flying. Make sure you share the content, my friend. If you're watching these things, please share. Come. This thing's taking forever. So, we're talking about the impact of heat, né? Let's talk about the impact of heat. Come on. Why? There we go. Boom shakalaka. Okay, let's go.
Heart-stopping new video of that deadly train crash in Spain. We now know at least one American on board among the 80 killed. And look at this.
80 people killed
that
on this
train
railway accident.
rocketing down those tracks, slamming into a barrier caught on tape.
Oh,
Tonight,
shit. Oh my goodness, the thing just left. Okay,
stopping new
there we
video
go.
of that deadly train crash in Spain. We now know at least one American on board among the 80 killed. And look at this tonight. That train rocketing down those tracks, slamming into a barrier caught on tape. Tonight, the driver of that train will speed before the crash. We now hear from an American.
That is be fast. Ne? But did you go check at the factors? Stop messing my class. I'm online. When you're looking at the fact here, is that we understand that he was coming fast and then he kept it. But there's also the element of heat that could have been part of the story. Because this train is designed to be fast.
Speed before the crash, as we now hear from an American on board. ABC's Nick Schifrin is at the scene in Spain tonight.
The moment of impact. The train racing around the bend and then violently careening off track before the camera cuts out. Watch again in slow motion. Right there, experts say that's the critical moment. The second car begins to leave the track, setting off a chain reaction. Each passenger car carrying 25 people, and then the engine twisting and toppling.
Yeah.
The driver reportedly admitted he was racing 110 miles an hour, more than double the speed he was supposed to be going.
That was extreme. Yes,
It was too late for him to take.
There was an issue of speeding there, but these are factors that can be considered. And then you've got the Tacoma Bridge, the famous bridge, and this one was designed in a way that abongo allow the wind factor and the fact that the bridge should be able to expand and collapse. This is way back in 1938. Yeah, there you see. There's the Tacoma Bridge.
During construction, we see the steel girders, 8 feet tall, which were supposed to stiffen the bridge against bending. However, some up and down vibration was observed during the entire useful life of the bridge.
And then they even opened the bridge. They came, the people, they were happy. November 7 at 1940. And now this one is a combination of, look at
the
that.
bridge suddenly went into a twisting motion. The wind speed was a steady 42 miles per hour. This was enough to keep the bridge oscillating.
This is because Woipata Kandirane is crossing a windy place. And the calculations did not allow for the wind factor and the expansion. And look at that. There's a guy who even tried to go to the car. They will not go to
engineering went out to see what had happened. He's coming back, walking with some difficulty. Along the center stripe of the roadway.
Hey, look at that. The Muya is doing that, and it will take time. So when it's very big and the wind gets stronger, this is what happened. And it's too big that it's wobbling, this thing.
This is photographed at normal speed.
You think it's not true? It's very clear and it makes so much sense to me. Hey, what the fuck? Okay, 700. Oh, yeah, good. All right, sure.
Had been abandoned earlier. No one was injured in the whole affair. However, a small dog.
And the wind became stronger and stronger and stronger all the way until the bridge collapsed. See there. And we're going to open here. The entire place is very open here. So lucky enough, you to remember their warning is at it gave them a warning that wobbly. So they got everybody out and now they were just waiting for it to collapse. It's very strong. So it got that system to collapse. And then I think I can check you out the gas explosion in a power plant. Now you do a heat expansion. This was, let's hope I still have that. Do I still have that thing? Shoot. Gas explosion in a power plant. Caught on camera, chemical. And I think it's, which one is this? Oh yeah, this one. Yes. Check this explosion. And when you talk about heat, there are so many things that can happen. Check this situation and tell me what you think. There is a power plant. The plant here, you know, Chevron or Caltech. It's a power plant, and somehow someone left a valve open, and there was an element of heat, and the spark ignited, and boom shakalaka. Cool. Check. Gone. Time up. I don't think you made it, that guy. So these things happen in a split of a second. Look at that. The fire, anyone who rides in next year, but anyone to buy chips. Another game of one again. You're nice, some two boy. No what? No, you do go now. More up. I don't love watching go. Oh, can you see the amount it took? Can you see the amount of time it took? I think they also have a video of a different angle. These guys. Yeah, I think they've got a video of a different angle. Obana pipeline issue in a leak. Oh, is it this one? No, it can't. You see, it's packing here. It's very, very critical. How do you want to flop or kill? Go on. Go on, guess a pallet of what was what was Shuma planting. Dimshimon is what the wood, yeah. And then the gas area, but you're going to look of very bad. Eli. Imagine I'm a piece of all how you are. Nanga. Very bad. So these things happen in industry and it happens at all the places. I'm also just very fortunate that I never came across this. I worked in very, very dangerous places. I worked offshore. Now offshore, una element here. So let me show you an offshore explosion or an oil rig. Ramande says, "Gori apalani ka oil rigi, apalani." I don't want to hear 10 minutes of the following first. Sorry. Yeah, well, there's always some camera that's gonna record this shit. Definitely. Let's check this guy. Maybe it will have some good explosions. Okay.
When an oil well discovers a
Apo vapo kodalithatha Bollywood.
sometimes occur, which is an uncontrolled release of oil and gas. Today's video is on the top 5 oil well blowouts. Number 5. A small oil well blows. After discovering an underground lake of oil, workers now must seal this hole quickly so they don't lose the valuable resource.
Z. Apa adospaka mlilo phezu chofara hapo. Batofa bona. Ukona H2S hapo. This is a gas that is invincible and it's deadly. Anotakuwa mlilo phezu the explosion. Dika rig hapa, dika platform ya rig side hapo. Okay, what about I think this thing is falling or what? As you know, the phenomenon that causes this, it's like if you take this water, this thing, and it's full, you close it and you do this. What happens? It's got this. So the oil operates the same way. Now, when you are cracking, when you are drilling, you get to drill a point which has a very high pressure, and air pressure is too much more than what you are drilling. What is happening there? And this explode. This is mixed up with H2S. It's that gas that's very flammable, and you die instantly. I'm gonna show you the one that really explodes. So these things that we do, my friends, very dangerous, lots of money, but very risky. Very, very risky, but lots of money. But nonetheless, what time is it? Are we on 5? I think some people should get their transports, no? All right, so did you give each other homework? No. Where? Oh, Kulapeti, Abaim. 4.2 is just theory. Hello. Number 4, number 9, number 11. Number 4, number 9, number 11, 4.2. Number 4, number 9, number 11, 4.2. Number 4, number 9, 4.2. Boom shakalaka. 4, 9, and 11. Yanabala, can't be remember what to comment out. Yes. Joshua Tabelo Papuri, yeah, King Saluto, big fire. Adam Durum, yeah. Adam Basha. Kakim Trapane, Ola, my guy, Trapane. Big love to my boy. It's nothing but love, you know what it do. All right, guys, thanks for the business of today. Thanking you, boy. Awe. Thank you so much for the support, my friends. Watch these videos, share these videos. We are teaching Africa these things, guys. We are teaching engineering. We're taking it to the next level. Pomshagalaka. Thanks for the love, Mtapane. Thanks for the love, Joshua. Big love. Keep sharing. Keep showing love. There's the love. Pomshagalaka. End broadcast. I shall see you guys in tomorrow's class versions. Hasta la vista. Boom shakalaka.